5.3, number 155. It says the same thing. Use the fundamental theorem of calculus part 1 to find the derivative. We have a new derivative. It's still, of course, the derivative of an integral, a little more complicated. It says cos x to 1 root 1 minus t squared dt. All right, so there's two extra phenomena here that the first problem did not possess. One, we see that here it was constant to variable, and here it is variable to constant. So they reverse the order of the limits of integration. This is a problem. Not only that, this is not just a variable, it's a variable with a rule. It's a whole other function. It's not just the x variable, it is a function of x. This is the second problem. And this is about as complicated as it gets. It's not a big deal. So the first thing we're going to do is we're going to switch the limits of integration. And if you recall, one of the rules for definite integrals was if you switch the limits of integration, you have to introduce a negative, as we decided before. I'm going to put an extra negative out here and switch these two, 1 to cos x. That looks more like the fundamental theorem of calculus part 1 now, because we now are going from constant to variable, at least a variable expression. Okay, so now all we have to deal with, we got the negative taken care of in the switch here. All we have to deal with now is the fact that this is cos x instead of x. So the way to think about it is as a chain rule. When it was going from 1 to x, or anything, doesn't matter, I know these are both 1, it doesn't really matter, constant to x, all we did was replace t with x. Okay? But now we have, instead of just the variable x, we have a function here. So this is like a function, right, composed within some larger integral function, you might say. Right? So this is a chain rule. So therefore, the derivative as applied to this should produce the function itself, right, at first, because that's what the fundamental theorem of calculus part 1 says, right, that the derivative process and the integration process are inverses and undo each other, leaving us with the original expression inside here. One process undone by the latter process produces the original result inside. So to here, we should get negative, because of just carrying over from here, but the integral and derivative process will undo each other, leaving us with root 1 minus, if this is the inner function, and we're thinking about chain rule, then inner function stays the same. So inner function inside here, cos x, quantity squared, let's put a little 2 here like it should be. Okay. So just like here, I replaced t with x, so to here I replace t with this function of x. Okay. But I'm not finished, I haven't finished up the chain rule. I've only done the outer function, right? This is like the outer function, and cos x is the inner function. I've got to complete the chain rule now of the derivative by multiplying by the derivative of the inner function cos x, which we know to be negative sine x. So negative sine x completes the chain rule. Okay? It's kind of a complicated looking chain rule because you're not used to seeing, well, integrals maybe at all, and then, you know, functions inside the limits of integration. So it looks kind of odd at first, but if you just think about it through the lens of chain rule, it becomes pretty obvious what to do. These negatives will cancel, and so we get root 1 minus cos squared sine x. Now, it is possible to simplify this a little bit. 1 minus cos squared, this is just unique to this particular problem. 1 minus cos squared is sine squared, so we get the root of sine squared x times sine x. All right. The root of sine squared is not just sine, it's absolute value of sine. Right. So we'll get magnitude sine x times sine x, something like that. All right.